Hello, and welcome to EC&M Asked, a Q&A video series in which readers pose their most pressing electrical questions, and our subject matter experts answer. Brought to you by EC&M Magazine and found on the members-only section of our website. I'm Tommy Northcott, Senior Power Engineer and Branch Manager with Jacobs. I'm here today to answer more of your questions about arc flash hazards, so let's jump right in. Today's first question is an interesting one. Is there a way to estimate the blast radius for debris during an arc flash event? Technically, yes, there is, but it's not very practical. The standard calculation for arc flash is a calculation of the thermal energy that can be generated in an arc flash event. This includes the distance that thermal energy can travel if unimpeded. This calculation is intended to protect personnel from receiving burns due to the arc flash event. However, debris from an arc flash event would be a result of the magnitude of the arc blast associated with the fault, combined with the integrity of the equipment involved in an arc fault. In fact, I have performed this type of calculation for a client who had a high voltage bushing failure that resulted in porcelain being blown through the walls and windows of nearby buildings and scattered all around the area. They were concerned about other bushing failures on their other transformers and the potential for injuring or killing personnel that might be in the area. We spent weeks analyzing the pieces of porcelain, the available fault current associated with the arcing fault, and correlating all of the investigation information to some DoD studies on the lethality of shrapnel. I used this information to give the client the probability of a similar event being a risk to personnel to help the client determine the safest way to return to operations until they could get the rest of those bushings replaced. But you can imagine how the potential for debris is heavily dependent on the specific details of each piece of equipment and sometimes each specific enclosure or cubicle. So it would not be practical to do this kind of analysis on any kind of broad brush approach. There's no single equation or set of equations that will be directly applicable in every scenario. However, you may remember from my discussion on 40 calories per centimeter squared limitations in a previous episode that there is a difference between the arc flash hazard and the arc blast hazard. The potential for debris is more related to the severity of the arc blast hazard, which is driven by the available fault current. With that in mind, one could use the rule of thumb that for equipment with high available fault currents, there will be a higher probability for debris, which can drive some decisions in your hazard risk analysis process for that particular task. The next question is related to client-owned facilities. We have electrical workers who work in client-owned facilities that do not have active maintenance programs. How can we assess the impact to the arc flash hazard from not performing maintenance on the equipment? Well, this is a very important topic, one that is related to why the NFPA has asked the NFPA 70B committee to turn that maintenance guidance into a standard like the National Electric Code and the NFPA 70E. Electrical equipment maintenance is directly related to personnel safety. The easiest example to use to communicate the significance of the impact of maintenance on safety is looking at circuit breakers. First, let's remember that the severity of an arc flash event is most directly impacted by the available fault current on the system and the amount of time it takes to clear that fault. So what does a circuit breaker do? Breakers are designed to clear a fault on a system to minimize potential damage due to the fault. Every circuit breaker has a designed clearing time defined by its TCC curve. You can imagine that if there is no maintenance being performed on a breaker, dirt and debris can start to build up around those moving parts of the breaker. In some extreme cases, you can even have contacts of breakers that weld themselves together. Either way, this can result in a breaker responding slower than it is designed to operate. If the breaker operates slower, the fault clearing time becomes slower, which results in a higher than the calculated incident energy level. This could mean that the personnel could be exposed to higher energy levels than the previous calculation that was posted on the sticker on the equipment. Unfortunately, there's no way that I know of to calculate or anticipate this impact. So what I do when I'm at a client's facility with this scenario is first, I do what I always do and try to figure out how to complete the task without requiring me to be exposed to a potential arc flash event. If that is infeasible, and I know there are inadequate maintenance practices, I will wear the maximum calorie rated PPE that I can to provide myself with as much protection as possible, regardless of what the calculations might say. The NFPA 70E does require that we consider the condition of maintenance during our hazard risk assessment and make decisions in accordance with the overall probability and potential severity. The bottom line, equipment maintenance does indeed make a difference in the effectiveness of electrical safety practices. So that should be included in your hazard risk assessment. We have time for one more. To effectively perform thermography scans in electrical equipment, the equipment must be energized and loaded, and the conductors needed to be scanned must be visible, which requires removing covers. Is there a risk of arc flash with this task? Yes. Anytime the covers are removed and energized parts are exposed, we must perform an arc flash risk assessment. Typically, when performing IR scans with covers removed, the personnel performing the scans are frequently inside the arc flash protection boundary and must be properly protected. When possible, it is suggested to remove the panels first while the equipment is in an electrically safe work condition, then energize and load the equipment and perform the IR scan. Even better than that, the next time the covers are removed, install IR windows in the appropriate locations so that future scans do not require removal of covers or exposure to potential arc flash hazard. The savings of no longer needing to remove and install the covers during future PMs will very quickly provide the payback to justify the purchase and installation of the new IR windows. It looks like we're out of time for today. I'll pick up next time with more answers to your technical questions. And remember, if you have a question you would like answered, please ask it in the comment section below, and maybe you'll get your answer on a future episode. Thank you so much for joining us on this edition of EC&M Asks. Check back in for future episodes coming soon. Thanks, and have a great day.